Okay, welcome back. So in this example 3, we're going to do example 2 again, but with the same xt but with initial conditions. So we are trying to solve this problem here. We have the same cosine 1t, and we have some initial condition, and we have that decaying exponential as ht. So we are going to solve for the new thing we are solving for is with initial condition. That means we are solving for y0 input because we already have y0 state. Okay, all right, let's see. So repeat, we are using example 2. Example 2, we have the input as cosine. The initial condition is 0, so we have the 0 state. We have the answer already. So now the initial condition given to us is at time 0, y0 is equals to 3. We have a new initial condition. So we want to find the 0 input response because we're going to set input to be 0, but we are going to give the initial condition y0 equals to 3. Once we have done that, we have found yit. We plus with yzs in example 2, and we get final answer. So you realize that because we already have found y0 state, we are not going to do this again. We are only going to do yzi in the next page. Okay, so now again we have the cosine. We have the same h of t, which is this guy, and now we are given this guy, y0 equals to 3. So what do we do? Alright, we have to find first the differential equation that is given to us from this information, because only from the differential equation can we insert y0 in later on. You'll see. Okay, let's try. So first is, if we are given h of t, we can do inverse, sorry, not inverse, we can do Laplace transform, and we get h of s. Alright, what do we do? Well, we have we are just going to express h of s first as ys equals to xs, which is what is the expression given to us. And now with this is we can bring the new denominator to this side and the denominator to this side, so that we get the Laplace domain representation, ys on the left, xs on the right. We open it up. So this is our differential equation in the s domain, but this is not what we want. We want the differential equation in the time domain. So this is the inverse Laplace transform, and then we get this expression back. So this is Laplace transform. The other way around, inverse Laplace transform. Why do we want to do that? Because we want to insert y0, the initial condition. It's now given to us. It's now non-zero, so we have to insert it here. So the only difference between this equation over here and this equation over here is that y0 is there. Once we have this, we can now take the Laplace transform again. And once we take the Laplace transform, then we can, the initial condition is now inserted in. Now, remember, when we are playing with the initial condition, we are not playing with xs. So this is 0. Alright. So let's now keep on evaluating. So we have from this point A, we now go to point B, and we have ys bracket s plus 1 minus the initial condition equals to xs. Alright, in my example, I kept xs for you, but let's see what I did with it. So finally, I moved this guy onto the right hand side, which is here. Now I will move s plus 1 to both the denominator. This looks very familiar. This is example 2. exactly? We have already solved for it. The answer is this guy, and then the time domain is this guy. So we are not going to repeat this. So we have done this in example 2. What is left is this guy. The initial condition y0 divided by s plus 1. In this example, it's only y0. If I have higher y prime 0, x prime whatever, I mean, there'll be more initial conditions. So, but in this example, we have only 1 prime 0. Actually, I've never really figured out whether the initial condition from x will come, but I don't think so, because x is what do you call that? X is the input, and in the 0 input condition, we'll ignore all x anyway. So I guess only the y will pops up. Alright, so now anyway, we have a 0 initial condition. Sorry, we have an initial condition with 0 input. So let's solve for this. So let's put y0. y0 is 3 over s plus 1. Now this is trivial then. So the ys of a 0 input is simply this 3 over s plus 1. Therefore, the time domain is 3e minus 1t by lookup table, and the complete solution is y of 0 state, which is example 2, which is this complicated equation here, plus the 0 input, which is due to the initial condition here. Now, what then I want to show you is that this guy is the steady state, it is the cosine running around with 0.071 amplitude and the phase shift. This guy, these two guys together forms the transient. So the transient has now an additional term. This is the additional term due to the initial condition, while this guy was due to the input. So it's quite complicated, the transient. The total transient is sum of two transient. Alright, let's draw the figure. Again, I use MATLAB to solve for you. This is the transient, the sum of the two transient. Let's see whether I get the numbers right. It is 3 minus half 3e minus 1t minus half e minus 1t. So this guy is 3e minus 1t. It is the transient due to the 0 input. So this guy, the 0 input. What about the 0 state? So I have drawn for you the 0 state. So let me now draw in red. This 0 state is this bubble here, or this bubble here is the 0 state. So remember, only after some time it reached 0.701. Before that, it was a small guy. Together, they make y complete. Why is y complete? Is this red crosses here. It is the green guy, the green circle plus the green straight line. Together, they form y complete. So y complete, it is very, very obvious that only after maybe this time onwards, this is steady state. And before this time, it is a transient. Okay, it's very nice. And the blue guy is of course the input. Now, to do all this in MATLAB, maybe again, the real problem is only this line of code. The rest is just plotting. Take a look at what I do. First, I have the impulse response. I Laplace the impulse response. I have x of t. I Laplace the x of t. I have the h of s of x of s plus y0, the initial condition. So this is the only thing I did. I add the initial condition here because I know the equations in the Laplace domain as in here. So this is the equation that I have inserted into my MATLAB. Okay, is xs over s plus 1, y0 over s plus 1. So if you look at this, what I did carefully, this is what I have done. hs times xs, hs, xs, and as well as y0 here, plus y0. Alright, so you can play with this and you'll get the answer from the last line, yt equals to inverse Laplace. The rest is just plotting. Okay, so with that, I end my examples of zero state and zero input. Thank you.